Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled Sharpless 249 and the Jellyfish Nebula. So what do we see here? Well, here we see two different nebulae in the same region. To the upper left, we see a red emission nebula. That is known as Sharpless 249, and it fills a large portion of the upper left of our image. This is an example of an emission nebula, which is essentially hydrogen gas, which glows red when excited. And how do you excite hydrogen gas? Well, it takes ultraviolet light from a nearby star, and that light will ionize the hydrogen atoms, strip off their only electron, and when they recombine, it will then go through various energy levels, and a prominent color that it will give off in the visible portion of the spectrum is a deep red color, and that is why an emission nebula like this one has that red tinge to it that we see, very distinct in its appearance. Now, down below to the lower right hand side, we see another one, and this is known as the Jellyfish Nebula. Now, it also glows from the emission of light, but it is a different type of nebula. So this is what is known as a supernova remnant. And you might guess from the name, a supernova remnant occurs when a star becomes a supernova and explodes, expelling its outer layers out into space at very high speeds. And that's what we see in the jellyfish there. Those are the outer layers of the star being expelled outward. Toward the center of that nebula, you would find a neutron star, much as we find in other supernovae like this. And that is the collapsed core of the star that has condensed down about as tightly as matter can possibly condense. What has happened is that all of the electrons have been pushed into the atoms. So you've squeezed out all the space between the electrons in the atom, and then squeezed all of the electrons there. Essentially, you have a gigantic nucleus, and you've taken something that may be 2 or 3 times the mass of our sun and condensed it down to the size of a city here on Earth. So it is incredibly dense and often very rapidly rotating, which we sometimes see as a pulsar when it emits beams of light. Now, supernovae do occur all the time. We don't see a whole lot of them in our galaxy simply because of our positioning in it, and it's hard for us to see lots of regions of our galaxy. Many of them are actually hidden from our view. But in other galaxies, we find lots of supernovae, and in fact can detect thousands of them in a given year now. And the Jellyfish Nebula was the remnant of what is classified as a Type 2 supernova. A Type 2 supernova occurs at the end of the life of a massive star when it becomes unstable and explodes. There is another type of supernova, you might guess it's Type 1, and it is, that occurs when another type of compact star known as a white dwarf becomes unstable. But this one is actually a Type 2. What happens when a massive star, something 30 or 40 times the mass of our sun, reaches the end of its life, becomes completely unstable, and explodes. And that only happens to the most massive stars. Our sun will never become a supernova. It is not near massive enough to reach that instability level that is needed for the entire core to collapse and then explode. So that was our picture of the day, titled Sharpless 249 and the Jellyfish Nebula. We'll be back again tomorrow for the next picture. So until then, have a great day, everyone, and I will see you in class.